So welcome back, guys. So we are talking about biostat, right? We are talking about biostatistics. We have talked about so many important topics in the biostat, and we are continuing now to the correlation, right? Now let's talk about the correlation, guys. Correlation, if we talk about, usually what we are saying about correlation, we are correlating this thing with the other, right? Correlating that thing with the different thing, right? So in the biostat, we are saying what is the correlation? Correlation, we are saying that basically it expresses the strength and direction, right? Two things you need to remember over here: strength and direction of relationship between two variables, right? Of relationship between two variables, right? In terms of correlation coefficient. Okay, what do I mean by this definition, guys? You look, we might be having two variables. Now these two variables might be, it might be the quantitative variable, it might be the qualitative variable. Remember, we have talked about the data, we have talked about the quantitative and the qualitative data already, right? I hope everyone remembers that. Now the variable can be anything, on the graph. If I'm talking about, this could be the y-axis, this could be the x-axis, vertical could be the y, horizontal could be the x, right? On the y-axis there could be one variable, on the x-axis there could be one variable, right? And in this particular graph we are talking about two particular things. One is strength and other one is the direction, right? So strength and direction of relationship between the two variables, strength and direction relationship between the x and the y variable will be actually calculated by the correlation. So that is basically the correlation. Simple definition: it is having the range, the correlation is actually calculated in terms of correlation coefficient. Correlation coefficient, we are using the alphabet over here, one alphabet over here, one symbol for the correlation coefficient is small r, that is a small r, and we are saying that small r is having a range between -1 to +1. So it should be there between -1 to +1. If the question is telling you that correlation coefficient is like 1.5, so that is wrong in itself. That is the wrong calculation of the correlation coefficient. So in that case, you need to choose an option. This is the wrong calculation, right? Already once they have asked you one question that the correlation coefficient was given, it was given as 1.8. So 1.8, you are thinking that it is beyond 1 obviously, and what I told you, what is the range of the correlation coefficient? That is -1 to +1. So above +1 and below -1, that will be termed as the irrelevant calculation as far as correlation coefficient is concerned. So correlation coefficient is having the range. So small r varies between, small r, that is the correlation coefficient, it varies between, this is just the symbol for the between, right? So between -1 and +1, -1, right, and +1. So please do remember this particular range for the correlation coefficient. One more thing over here, if we are talking about the correlation over here, we are talking about the correlation coefficient and the symbol over here which we are using, that is a small r, right? Now two things over here I am telling you. One is the sign of coefficient. Sign of coefficient is actually talking about, sign of coefficient is actually telling us about the direction of the relationship. I told you what kind of things we are talking about: either direction, either strength. So direction will be calculated by, will be known by what? It will be known by the sign of coefficient, right? So direction, it will be telling us about the direction of relationship, right? Direction of relationship. Okay, and if we talk about the value or size of coefficient, then it will be telling us about the strength of relationship between the variables, right? It will be telling us about strength of relationship between the variables, right? Okay guys, so over here I would like to highlight that we are talking about two important things over here as far as coefficient is concerned, that is the direction and strength. Direction and the strength. And we are talking about the correlation coefficient, that is having a range between -1 to +1. It is actually, we are describing that with the help of a symbol, that is the small r, right? Next point over here, if we talk about the coefficient, right? If we talk about the coefficient of correlation, it will be, if it is I told you first thing that the range is -1 to +1. Second point over here is that if it is strong or if it is weak. So in what conditions we'll be saying that coefficient of correlation will be stronger or weaker, right? So in case if coefficient of I'm just writing small r over here. I know you are understanding that small r means coefficient of correlation, right? Small r would be strong. Small r would be strong if small r would be strong, and in other case small r could be weaker also. I told you the range already, that is between -1 to +1, right? If it is in between ±0.5 and 1, then usually it is strong. We are saying that if it is between ±0.5 and +1, then it is termed as that coefficient of correlation or correlation coefficient would be generally stronger, right? Either between -0.5 to 1 or between +0.5 to 1. And it will be weaker if it will be between ±0.5 and 0, right? Then we will be considering that small r as weaker component over here, right? Always remember, guys, that data which we are representing, data which will be representing over here, it will be plotted in the scattergram or the scatter plot. It will be plotted in scattergram or scatter plot, right? What is this scattergram scatter plot? This is the scattergram or the scatter plot which you can see right now in the front of your picture, right, in the front of your screen. Here what I can say that just there are the scatters, that right. So this is the y variable over here, this is the x variable over here, right, and we are talking about two things over here. One is the strength and another one is the direction. Okay, I told you guys already about that strength. So one point we are talking about strength and direction over here, strength and the direction of relationship between the two variables, right? So one variable would be x, other variable could be y, right? So here we can see this is just the scatter, this is the scattergram. So that's why we are calling that as scattergram or the scatter plot, right? So that is a simple thing over here, right? Now guys, if you talk about the correlation, we are having two types. One type is the linear, other type is the non-linear. So either it could be having the linear correlation or the non-linear correlation. So let's talk about the types as well, but before that let me talk about some important points over here. In the front of your screen you can see some of the diagrams, what it is representing. Let me talk about that. All of them, first of all, these are the scattergram, right? All of them, these are the scatter plot or scattergram first of all. And among this scattergram, what I can see, first one, look at the first one, we are calling that as perfect positive correlation. Correlation means correlation coefficient, we will be actually symbolizing it with what? Small r, right? So we can say that small r will be in between -1 and +1, and we can give the name also, we can give the value also. I will come to that. But for example, right now what you can see, if the scattergram is telling us, if the scattergram is showing us that it is showing the direction in the positive direction, I mean showing the scatter in the positive direction, then we'll be saying that this is the positive correlation, right? As you can see, this is the perfect positive correlation. Usually what we are doing, this is the scatter, right? And we will be drawing an imaginary line over here. We will be drawing an imaginary line, right? So imagine, you can see that all the scatters over here are actually surrounding the line, are actually very close to the line, and they are actually strongly adhering to each other. But over here, if you will go to next diagram, you can see that if I will draw the imaginary line, the scatters are a bit separated over here as compared to the first one. So here I can say that this is the perfect positive correlation. The first one is the perfect positive correlation. The second one is the strong positive. It is a strong positive, but not the perfect one, because bit of scatters are present over there. There might be some disturbance. If you talk about the line, from the line you can see that they are little disturbed. Then if you will go to the next diagram, guys, here the scatters are very much disturbed over here. If I will draw the imaginary line over here, right, so they are very much disturbed from the line basically. So I can say that yes, it is positive because it is going in the positive direction only, but it is weaker positive correlation, right? And if it is going in the negative direction, then we'll be calling it as negative correlation. Here there is no correlation. If I am drawing the line, right, I am not able to draw the line over here because equal amount of scatters are present over there, right? So we are not, we can draw the line like this also, we can draw the line like this also. There is no direction. If there is no direction over there, for example, here we still had the direction, like this, isn't it? But here we are not having the direction, so that's why there is no correlation. So either the correlation might be there, right? It might be the strong correlation, it might be the weak correlation, that is the first thing. It might be the positive correlation, it might be the negative correlation, that is the second thing. Or in third thing, in some scenarios there might not be the correlation as well, that will be called as no correlation. For example, you are seeing in this picture, if you will seeing this one, here the direction will be, if I will draw the imaginary line, it is something like this. So direction is towards the downward direction, so that is the negative, right? That is a negative correlation. So this is called as the weak negative correlation, because scatters are apart. Now here this will be called as the strong negative correlation, and this is the perfect negative correlation, as you can see over here, that the scatters are perfectly aligned, right? Okay, once we have talked about that, now look over here guys, what I can see that we have already talked about the perfect positive correlation, we have already talked about the high positive correlation, or high positive, I mean the strong positive or the weaker positive, or the right, that thing. So perfect positive, I told you that R will be over here, that will be the +1. So R over here, that will be the +1. Okay, R will be +1, right? +1, as you can see, plus over here they are writing like that. Okay, if it is high positive correlation, right? If it is high positive correlation, in that case you can see that it is the strong positive correlation. I am saying that, look over here, this was the strong positive correlation and there was a weak positive correlation. So right, so this is the strong positive correlation and this is the weak positive correlation, right? As you can see, if you will draw the line like this, it will be like this, right? So you can see the strong and weak positive correlation. Here the R will be approximately around +0.9 and here the R will be approximately around +0.5. What I told you, usually, right, usually the R value will be varying between +1 and -1, so do remember that. Now look over here, now this is the, here we can see the R will be -0.5, here we can see R will be -0.9, here the R will be -1. So +1 would be for the perfect positive correlation, it will be the +1, right? And it will be -1 for the perfect negative correlation. Okay, so that's the thing, or that's how it is varying. And what is this? This is the scattergram. This is the scatter plot or scattergram. So the coefficient basically, or the correlation coefficient, we are actually defining them, the variables we are defining them. What we are defining, basically the strength and the direction of the relationship between the two variables we are defining by the correlation, and we are having a coefficient due to that. Coefficient for that, that is the coefficient of correlation, that is represented by the small r. It is varying between -1 and +1. There might be different scenarios where I told you that it could be having the r equals +1 or -1, like perfectly aligned, or there could be the strong positive correlation, weak positive correlation, strong negative, weak negative correlation, perfect positive correlation, perfect negative correlation. All of these scenarios we have talked about, right? As far as types are concerned, guys, we shall talk about the types over here as well. So types, we can say that, what could be the types over here? One could be the linear type, first one could be the linear type, second one could be the non-linear type. Okay, second one could be the non-linear type. Mind you over here that non-linear type can be called as curvilinear, guys, right? Non-linear shall also be called as the curvilinear type of graph over here. Okay, now linear, if I'm talking about, then it is also having the name, guys, please remember that, that is the Pearson Called correlation, and this is also called as the Spearman correlation, that is the curvilinear or the non-linear type of correlation, right? In the linear one, guys, we are talking about usually r equals +1, -1, or is in between +1 and it could be +0.5, it could be -0.5, and all of these things we have already talked about, right? So that is about the linear, right? Non-linear means it is not having the direction per se. One is the no correlation, that is a different thing. Here in the non-linear, we are saying graph. If I will be drawing the graph, it will be like this. This is the graph over here, and the scatters will be like this. The scatters will be like this. The scatter I can draw like this. Okay, so this is something like, this is the scatter. right? So this is the curvilinear. So if I'm drawing the, if I'm drawing one line over here, so I shall draw the line like this, isn't it? So this is called as the curve. So this is the curvilinear. So this is kind of a scatter. So this will be the scatterogram or scatter plot for, this is the scatter plot for the curvilinear. Are you understanding? So I hope you understood about that. Now one more thing we need to talk about as far as correlation is concerned, that is the determination, coefficient of determination. So let's talk about that as well, right? So let's talk about coefficient of determination. So one more guys, one more thing over here, as you can see that how the non-linear is looking over here. As you can see, this is the graph of the curvilinear, this is the graph of curvilinear, and you can see this is the linear correlation, right? Linear correlation will be having the straight line, right? And the curvilinear, this is also called as the curvilinear or non-linear correlation, okay, right? Now after that we shall be talking about the one more concept over here, and that concept is the coefficient of determination. Coefficient of determination. So what is coefficient of determination? It is actually, it might be referred as CD as abbreviation, CD as abbreviation over here, and simply it is saying that it is just double of the correlation coefficient, that is small r square, right? So over here we can say, simply what it is telling us, what is the mean, what do I mean by that coefficient of determination? It is simply percentage variability. Now listen to me very carefully. Percentage variability in one factor due to the change in another factor, due to change in another variable, right? I mean to say that, guys listen to me, simply I mean to say that what is the change over here which is happening? It is a unit change, it is a simply percentage variability in one factor. So it is change, for example, x-axis is actually changing, right? So due to this changing of the x-axis, what is the change we can appreciate in the y-axis? What change can be anticipated in the y-axis due to the change in the another variable, that is the x-axis? So there is the x-axis, this is the y-axis. If I am changing the x-axis, if some change is happening in the x-axis, what could be the change which can be anticipated in the y-axis? That is the determination of, that is the coefficient of determination, right? And it is calculated by r into r or r square, right? That means a correlation coefficient square. So that was about the correlation. Thank you.